Drawing the addition of vectors. We already know how to mathematically find, add, subtract, and multiply vectors by scalars. Now we will understand all of these things and how they look on a graph and how we can draw them. The technique to adding two vectors and drawing them out is to first align the head of the first vector with the tail of the second vector, then draw the resultant vector, and then finally we can calculate the resultant vector and the magnitude. So what this means is the first vector we have here, that'll be vector 1, and then we're going to take whatever second vector is, that's vector 2, we're going to take that whole thing and we're going to move it over there. So we actually have our second vector moved to the tail with the same magnitude, same angle, and everything. And then we're going to have it like that. Our resultant vector is going to be the one that's connecting the two ends. So that would be our resultant vector. So now we're going to talk about how to find these. Alright, so with an example here, we're going to add the vectors and find the magnitude. So the first thing we're going to do is find vector v. Vector v is going to equal 3 minus 0, which is 3, 2 minus 0, which is 2. So now I'm going to draw vector v where it's supposed to be. So its initial point was at 0, 0, and its terminal point is at 3, 2. So if I draw that vector, it's going to look like that. And now my vector u is going to be 4 minus 3, which is 1, 3 minus 0, which is 3. And now when I draw that vector, it's going to start at 3, 0, and then it's going to go to 4, 3. Alright, and now what I want to do to actually draw my resultant vector is I want to put them end to end. So essentially what I'm going to do is I'm going to translate my vector 2, my u vector, up. So I'm going to move it up 2 to right there. So my resultant vector is going to come up like that. All I did was I shifted it up 2. And that means that my resultant final vector, when I add the two together, is going to be right there. That's going to be my u, my v plus u vector. Because this is my vector v, and this is my vector u. So that is my v plus u. So now if I actually find v plus u, I'm going to take 3, 2 plus 1, 3, which is going to equal 3 plus 1 is 4, 2 plus 3 is 5. So that is my addition, v plus u. And now I want to find the magnitude of v plus u. The magnitude of v plus u is going to equal the square root of, here we're going to want to make it into our right triangle. Okay, so go 1, 2, 3, 4 spaces and then up 5. So it would be 4 squared plus 5 squared. So that's going to give me the square root of 16 plus 25, which is the square root of 41. So the magnitude of u plus v is equal to the square root of 41. And that's your final answer. Okay, so we have drawn our resultant vector and found our magnitude. For this next one, we want to find our vector u, and u is going to be equal to 4 minus 3, which is 1, 3 minus 0, which is 3, and my vector w, which is equal to 7 minus 5, which is 2, 8 minus 7, which is 1. Okay, and then I draw my vector u at 3, 0, and 4, 3. So that is my u vector, and my w vector is going to be 5, 7. And 7, 8. So it's that vector right there. We want to add u plus w. So we're going to translate w down and over so that it's starts right there. So that makes it moved to right there. That's my w vector. And now I draw my resultant vector, u plus w. And now I can actually do the math. U plus w is equal to 1, 3 plus 2, 1, which is going to give me a final vector of 1 plus 2 is 3, 3 plus 1 is 4, 3, 4. So what that's going to tell me is when we are drawing to figure out our magnitude, we're going to go over 3 and up 4. So my magnitude of u plus w is equal to the square root of 3 squared plus 4 squared, which equals the square root of 9 plus 16. And that's the square root of 25, which is 5. So the magnitude of u plus w is 5. Alright, in this last example we have w, which the vector is going to be equal to 7 minus 5, which is 2, 8 minus 7, which is 1. And my t vector is going to be equal to 4 minus 1, which is 3, 5 minus 0, which is 5. Okay, so if I draw my w vector, 5, 7, and 7, 8. There's my w vector, and my t vector is 1, 0, and 4, 5. Technically, we can add either end to either end, so I'm going to actually just move my w vector down because I think that would be easier, and then it's going to come up like that. So there's my t and w vector end to end. So if I connect that, that would be my resultant vector, t plus w. So now I'm going to add t plus w. So I get 2, or 3, 5 plus 2, 1 is going to equal 3 plus 2 is 5, 5 plus 1 is 6, so I have 5, 6, telling me that when I am drawing on here to figure out my magnitude, I'm going to go over 5, up 6, giving me a magnitude of t plus w to be equal to the square root of 5 squared plus 6 squared, which is the square root of 25 plus 36, which is equal to the square root of 61. So that means the magnitude of t plus w is equal to the square root of 61. And that's your final answer. So those are your notes over drawing the addition of vectors. So really what we've done is we put together the mathematical way of adding vectors with the actual drawing of the vector and the resultant vector. Go through these practice problems and then you can prepare for your quiz over the material.